Hello and welcome back to Jerry Builds Things. Today I'm going to be tackling the next two projects that are in this 301 Electronics Projects Lab. The next project, from my memory, it is a little challenging, not because it's hard to put together. These days, an old style transistor radio like this has trouble picking up signal because there is so much other radio noise out there, but I'm gonna do my best. I have good ground. I wired this shop myself, and one of the important parts of a transistor radio was a good solid ground. And I actually have two ground rods for the service. So I hope that gives me a shot. So here we go. Once again, parts list. Oh, and I actually organized all the parts into this and labeled everything just so that it's easier, goes a little quicker when I'm trying to select all the components. All right, one 22K resistor. Here's a 22. 470K resistor. Hardest part is pulling these things out of here with my giant hands. There we go. One 2.2K resistor. Maybe I'll get some tweezers for the future to pluck them out. One PNP transistor. 0.01 microfarad ceramic capacitor. That would be a 103. Right, yep, 103. One germanium diode. And 14 wires. I'll just pluck them out as I need them. 22K resistor, J7 and G12. 470K resistor, H13 and 13. 2.2K resistor, H12 and negative. All right, that one's getting close to the other two. So you just have to be a little careful here. There it goes. 0.01 microfarad. All right. Transistor emitter pin in G15, collector in H15, and the base in J15. The flat side of the transistor faces left. Okay, the markings face left. Easy enough. Cathode pin of the germanium diode in J3 and the anode pin in J6. I don't know what that means, so let's consult the instructions. The diodes have a band on the cathode side. Cathode pin goes in J3, it says. J3. And the anode pin in J6. Connect the green antenna wire to terminal 33. All right, which is apparently just an extension on the actual tuning antenna that they have. Bada bing. One wire of the earphone. Talk about a relic from technology in the past. The earphone. One terminal, or one wire of the earphone goes to T1, the other to T2. All right. Connect the other long green wire between terminal 35 and an earth ground. So this guy is going to go to an earth ground, and I might actually have to use a longer wire to run it outside. It's just on the other side of this wall I'm up against here, so it's not too far. But it's a good earth ground. I can't remember how many feet of copper rod I had to put in by code for the electrical code book, but it might have been like 12 feet, 10 or 12 feet, something like that. So I have good ground out here. Terminal 35, right here. All right, so there's a ground. And then all the rest of the wires. I'm gonna pull out my fancy upgrade wires that I bought at Micro Center. J14 and N14. Let's see. There. Man, I'm geeking out over these things. I like these wires. J1 and 30. Let's see, 30 is all the way over here. All right, I'm gonna need a longer one, so I'm gonna go back to one of the old school. J1, 30. G11 to 35 to 32 to 31 to ground. Really? Let's look at the schematic, see how that works. G11 All right, G11 to 35. Oh, okay. All right, I'm just going to connect the wires like they say to connect them, but it seems like an awful... I don't know if it's a misprint. Hey, whatever. If that's what they say. I mean, I don't remember running into a problem with that last time, because I think this is the last project that I did. Yeah. I don't remember running into a problem with that, so hey, whatever. I'm going to... See, that shows you how much I don't know about electronics. I really got to study up here. All right, G11 to 35. That resistor to that terminal, 35 to 32. (32 to 31). 31 to ground. 29 to 34. G14 to 47, gonna be down here. I need a longer one than that one. H14 to T1. Negative to T2. Positive V6 to 48. All right, the next step is turning on the project. So what I'm going to do right now is run the wire out to the ground on the other side of this wall, and I will be right back. All right, so I have an incredibly way overkill connection to ground via a, I don't know, was that 8 gauge bare copper wire. There's about 20 feet of it, and I'm only going 6 feet around the corner, but whatever. More is better, I guess. So anyway, I have a good connection to ground. The trick might be the antenna, this weak antenna wire that I have. And I could not locate my auxiliary AM antenna that I have for my radio tuner out here in the garage. So I'm just gonna follow along and see what happens and hope I pick up a signal and consider this a win. Let's see, press the switch toward the word switch. This turns on the power. Put the earphone to your ear and slowly rotate the tuning capacitor. You will be able to hear some of the AM broadcast stations in your area. Let's see what happens. All right, I hear radio noise, so I know it's picking up something. Oh, I just lost my ground. That's fabulous. I just heard talking. It works! I think I'm picking up AM 1000 actually. This is incredible because last time when I did this, I could not pick up anything to save my life, and it might have been because I didn't have a significant ground out here. I think I was just using the ground on the electrical service before I upgraded it. I'm gonna put this earphone up to the the microphone I have and see if you can hear it. All right. Now that is quite literally the only station that I can pick up with this setup right now. I'm gonna see if you can hear it again. Success came early today. I know it isn't much, but I'm thrilled. The last time I did this project, I couldn't pick up anything. I do think that the difference this time is a good solid ground. You need a good ground to complete the electrical connection between the airwaves and the earth, I guess, to pick up the signal properly. I know it isn't much. It's an old style transistor radio with an earpiece designed from the late 1800s, but it's a win. And I mean, really, with messing around with it, I could probably get a couple more stations. So for now, I'm going to consider this project a win and move on to the next one. Before I wrap this one up, I'm just going to read through the end of the project here. How it works. The amplifier in this project amplifies the sound you hear in the earphone, the amplifier being the transistor. It does not make the radio more sensitive, able to pick up a weaker station, More complex radios have circuits which amplify the radio signals before they're changed to the sound. Now, I think later on in here, I could be wrong, but I think later on in this book, there is another project that is an amplified transistor radio. So now that that one's completed, I'm gonna move on to project number 3. I'm gonna take this apart, put away all the pieces, and start in on the next one. That radio project, project number 2, I anticipated that to be a real pain in the butt. Ended up being a softball. So I'm gonna move on to another one that actually should be a softball. Sound Scooper. Here's a different sort of amplifier. This one lets you listen through the earphone to sounds you send through the speaker. Therefore, the speaker acts as a microphone. All right, so I'm just gonna jump right in. One 220K resistor. One 1K resistor. One 100 ohm resistor. I've gotten pretty good at reading the color bands on resistors with this limited selection anyway. They're almost like flashcards. You just get pretty quick with them. One 22K resistor. One 470K resistor. One 2.2K resistor. NPN transistor. There's that. A PNP transistor. There it is. 3.3 microfarad electrolytic capacitor. 3.3. There it is. A 0.1 microfarad ceramic. It is a 104. Boy, these drawers make it a lot easier to find these parts. One 100 microfarad electrolytic capacitor. There it is. And 15 wires. All right, let's plug in all the components. 220K resistor in D8 and H8. 1K resistor in D10 and G12. All right. 100 ohm resistor in K8 and P8. All right. 22K resistor in K10 and N11. I know it seems a long way off, but I'm looking forward to getting through this kit and moving on to some Arduino and Raspberry Pi projects. Okay, 470K resistor in J12 and N12. And another side benefit to recording these videos is it forces me to keep a neat and tidy desk space, because usually I have a problem filling this thing up with random garbage. All right, insert 2.2K resistor in N14 and S14. Insert the negative side of the 3.3 microfarad electrolytic capacitor in G5 and the positive side in H7. Insert the 0.1 microfarad ceramic capacitor in J10 and J11. Those of you that are watching, the two of you, hopefully, at least, what kind of electronics projects do you like to do? Because I'm like random. My ADD kind of makes me, oh, hey, I like this. And then 5 minutes later, ooh, I like that. And then 5 minutes later, oh, I like that. So I kind of like a little bit of everything with electronics. I mean, I like mechanical things, electronics, anything with an engine, cars and trucks, space stuff. I mean, I like a lot of stuff. So within electronics, those of you that are watching, let me know in the comments what you like doing projects on. Okay, insert the negative side of the 100 microfarad electrolytic capacitor in G10 and the positive side in G11. There, good. Insert the NPN transistor's emitter pin in K6, the collector in J6, and the base pin in H6. Flat side faces right. Some of these projects I'm going to get out my tweezers so I can put them together because they're going to get pretty crowded. Luckily, I've changed about 3 or 4 smartphone screens, 2, 3, or 4 batteries, speakers, all kinds of stuff. More often than not, they send you tools to go along with the part that you just bought. So I only have 15 pairs of tweezers and spudging sticks and all kinds of stuff. So that'll probably come in handy with this. Insert the PNP transistors, emitter pin in G15, collector in H15, and the base in J15. The flat side of the transistor faces the left. I found a typo right there. The flashed side. Typos in the words. Hopefully there's no typos in the actual connections, because if something doesn't work right and it's because of the diagram being wrong, I won't know. I'm not an electrical engineer. GH and J15. Oh, that's an easy one. Boom, boom, boom. All right. Now it's connecting wires. All right, insert one wire of the earphone to terminal 1 and then the other one marked T2. There's terminal 1. There's terminal 2. And then wires. So let me just get out all of them just in case. G1 to 41. 41. P6 to 39. To 39. P10 to S11. P10, S11. S12 to negative battery row. Negative. T16 to 42. I don't need a yellow one. Blue one. T16, 42. V16 to 43. Going to be the same general location. So V16, 43. G14 to 47. So I'll run another blue wire. N15 to T1. N15 all the way over here. S15 to T2. Alrighty. T20 to T20, or T20 to number 27, terminal 27. And that is the speaker. So T20, all right, that should be a red wire. That shouldn't be too bad. V20 to 28, around the same area. It's a little further away, so we have to go with a blue wire on that one. Positive battery V6 to 48. And 48's all the way down here, so that's going to be a yellow wire. G9 to P9. All right. D7 to J7. Same thing, red wire. H13 to N13, another red wire. And that is it. All right, turning on the project. Press the switch towards the word switch. Put the earphone to your ear. Now rub your fingers across the speaker and tap on the front of the speaker. What do you hear? So, I hear nothing. That means I connected something wrong. So I'm going to go over this and figure out what it is. I figured out what I did wrong. I had a transistor in the wrong spot, and it's kind of obvious this one right here isn't connected to anything. I mean, one of the terminals is. I had it going the wrong way. Flat side faces right. K6, H6, J6. There it is. I'm not going to check the wiring. I think that was the only problem. So I'm going to fire it up and see if that was it. I am still about to call it a night. I don't hear anything yet. So I most likely have a wire disconnected or connected wrong. All right, back to the drawing board. All right, I'll go through the wiring now. I just discovered what it was, and I didn't have to look for very long. I have nothing connected to where the earphone connects to these terminals, because these terminals are meant to join two wires together, basically. So these terminals are T1 and T2. And I went through the connections and I looked, oh, here's N15 to T1, S15 to T2. Breadboard, T1 and T2. If you're not looking at the schematic or the breadboard wiring diagram, there's no differentiating in the wire connection chart when it's telling you T1, T2. It doesn't tell you if that's breadboard or here. You have to look or do a little troubleshooting when the earphone doesn't make any noise. All right, so let me switch those up really quick. All right, N15 to T1. There's N15, T1, S15 to T2. All right, now I am fully confident that this is going to work. No, really. Throw the switch. And I finally heard the click. It works really well, actually. Basically what this project does, it takes the sound vibrations that are hitting the speaker and outputs it to the earphone. Here, I'll put it up to the microphone. I'll tap on the speaker grill. If I tap on this, you'll definitely hear it. See? So that is the sound scooper, the how it works section. We know a speaker gives off sounds, but did you know that it can also work as a microphone? It can, because the magnet in the speaker gives off weak electric currents whenever sound waves strike it. Normally, a speaker doesn't make a good microphone, but in this circuit, we have enough amplification to make a microphone. Notice that we use 2 transistors in this project for increased amplification. That's project number 3. In the can, all done. So, I consider these last 2 projects a win. I'm glad to be done with them and moving forward. If you liked what you saw today, give me a like, subscribe, leave a comment, tell me what you think. I'm going to be moving forward with all these projects sooner or later. Got a lot of them. Number 4 is next. I got 300. Thanks a lot for checking out Jerry Builds Things. I look forward to bringing you a lot more videos of just every crazy project I can think of. So, all right, later.